You think your CPU only executes instructions that actually happen. It reads your code, follows it step by step, and produces a result. Clean, logical, predictable. But that's not what's really happening. Your CPU is running instructions that it later deletes, instructions that were never supposed to exist. And the strangest part, it does this on purpose. By the end of this video, you're going to understand why your CPU runs fake execution, how it erases it like nothing happened, and why something still leaks through anyway. Because even when your CPU pretends something didn't happen, it already did. When you write code, everything looks simple. Line 1 runs, then line 2, then line 3. But inside your CPU, that illusion breaks instantly. Modern processors don't wait. They don't follow your code step by step. They rush ahead. At any given moment, your CPU might be working on instructions that came earlier, instructions happening right now, and instructions that haven't even been confirmed yet. Yes, confirmed, because your CPU doesn't actually wait to know what happens next. It guesses. But here's the twist. It doesn't just guess. It acts on that guess immediately. So before your program even decides what path to take, your CPU has already started executing one. But what if it's wrong? Hold that thought. Because what happens next is where things get strange. Imagine you're at a fork in the road, left or right. You don't know which way to go yet. A normal system would stop, wait, decide, then move. Your CPU doesn't do that. It starts walking before deciding. It picks a direction and just goes. This is speculative execution, but don't think of it as a feature. Think of it as controlled cheating. Your CPU is saying, I don't know the answer yet, but I'm going to act like I do. And most of the time it works, because the CPU is very good at guessing. So instead of waiting, it gains speed, performance, efficiency. But sometimes it guesses wrong. And when that happens, everything it just did should not exist. So what does it do? It deletes it. Or at least, it tries to. Let's slow this down. Your CPU guesses a path, executes instructions, then discovers it was wrong. Now it has a problem. It already did work that should never have happened. So it performs a reset. It rolls everything back. It clears the results. It restores the state, and from the outside it looks like nothing happened. Your program continues perfectly. No errors, no glitches, no trace. But inside the CPU, something very real just occurred. Instructions were fetched, decoded, executed. Data was touched. Memory was accessed. And then erased. Or was it? Because here's where things stop being clean. What if you can't fully erase reality? When your CPU deletes speculative execution, it removes the official results. Registers go back. Program state is restored. Everything looks correct. But not everything inside a CPU is so easy to reset. Some things are indirect, like caches. When your CPU executes an instruction speculatively, it might load data into cache. That data stays, even if the execution is later erased. So now you have a strange situation. The instruction never officially happened, but it changed the CPU's internal state. And that change can be measured, not directly, but indirectly, through timing, through access speed, through behavior. And that means someone can observe what your CPU almost did, even if it didn't. Let that sink in. Your CPU can reveal information about actions that were deleted from reality. At this point, you might be thinking, okay, that's weird, but harmless. It's not, because if you can measure what the CPU almost executed, you can start extracting information, sensitive information, things like passwords, encryption keys, private memory. And here's the scary part. You don't need permission. You don't need access. You don't even need the code to run normally. You just need to trick the CPU into speculating, and then observe what changes. This is the foundation of one of the most dangerous classes of attacks ever discovered. But before we go there, you need to understand one more thing, because this behavior isn't a bug. It's the reason your computer is fast. Without speculative execution, your CPU would constantly wait. Every branch, every condition, every uncertainty, it would stall, pause, waste time. Performance would collapse. So engineers made a trade-off. Speed now, correctness later. Your CPU runs ahead and fixes mistakes afterward. Most of the time you never notice because everything gets cleaned up perfectly. But as you've seen, not everything can be undone. And that tiny gap between executed and erased is where everything breaks. Your CPU is not just executing your program, it's exploring possibilities, running alternate paths, creating temporary realities, and then deleting them. But those realities leave traces, and those traces can be observed, which means your CPU doesn't just compute, it exposes information about what it almost computed, and that changes everything. Because now execution isn't just about correctness, it's about what leaks through the cracks. And in the next video, we're going to take this exact idea and show how attackers used it to read data they were never supposed to see, not by breaking your system, but by watching what your CPU tried to hide. Your CPU executes code, then pretends it didn't. But now you know, it's not the execution that matters, it's what it leaves behind.